Alright, so in this video, I'm going to solve an interesting exponential equation. So my equation is 100 to the power of x is equal to 400. And I want to find the value of x. So we see that x is going to be in between 1 and 2 because 100 to the power of 1 is 100 and 100 to the power of 2 is 10,000. So it's going to be more closer to 1 than it is 2, but it's going to be somewhere in the range of 1 and 2. So to solve this, what I'm going to be using is logarithms. So I'm going to first start by taking the log on both sides. So I get log 100 to the power of x is equal to log 400. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so I get b times log a. In this case, I have log 100 to the power of x. I can move x to the front, so I get x times log 100 is equal to log 400. Now, I'm going to take the log of base 100. So, log base 100 of 100 is just 1. And log base 100 of 400, well, 400 is the same thing as 100 times 4. So I can rewrite this as log base 100 of 100 times 4, which is equal to log of 4 over log of 100. And I have 1 plus this because of this. So now log of 4 is the same thing as log of 2 squared. And log of 100 is the same thing as log of 10 squared. So I can move the 2 to the front and the 2 to the front over here. So I get x is equal to 1 plus 2 log 2 over 2 log 10. These two cancel out, so I get x is equal to 1 plus log 2 over log 10, which is equal to 0.301. So x is equal to 1.301. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 2 to the power of 24. So to solve this, I'm going to first start by rewriting 2 to the power of 25 as 2 to the power of 24 plus 1. So I have this minus 2 to the power of 24. And the reason I did this is because we want both of these to be the same. We want to have 2 to the power of 24s. So the best way of changing 2 to the power of 25 as 2 to the power of 24 times something is to rewrite this as 2 to the power of 24 plus 1. So now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So now 2 to the power of 24 plus 1 turns into 2 to the power of 24 times 2 to the power of 1. And I still have this minus 2 to the power of 24. Now, from here, what I'm going to do is factor out 2 to the power of 24, because notice how both of these terms have 2 to the power of 24 in them. So I get 2 to the power of 24 times 2 to the power of 24 times 2 to the power of 1 divided by 2 to the power of 24 is just 2 to the power of 1. And negative 2 to the power of 24 divided by 2 to the power of 24 is just negative 1. So I get 2 to the power of 24 times 2 to the power of 1 minus 1, which is equal to 2 to the power of 24 times 2 minus 1, which is equal to 2 to the power of 24 times 1. And this is just anything times 1 is obviously just equal to itself. So this is just equal to 2 to the power of 24. Now, from here, I'm going to rewrite this as 2 to the power of 12 times 2. So, the reason I did this is because I can now use the property a to the power of m times n is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is equal to 2 to the power of 12 to the power of 2. And 2 to the power of 12, well, 2 to the power of 1 is equal to 2. 2 to the power of 2 is double of 2 to the power of 1, so 4. And 2 to the power of 3 is double of 2 to the power of 2, which is 8. So this pattern goes on, and I keep on doubling this. Until I reach 2 to the power of 12, which is equal to 4,096. So this is my value for 2 to the power of 12. So now I get 4,096 squared. Now, what most people would do, well, first of all, 4,096 squared is the same thing as 4,096 times 4,096. And from here, what most people would do is they would just multiply this like this. So they do 4,096 times 4,096 and use the conventional method to multiplying it. However, this method takes way too long, and it's really easy to make an error using this method. So instead, to more easily solve this, I'm going to rewrite this as 4,000 plus 96 times 4,000 plus 96. And now I can use the distributive property. So I get 4,000 squared plus 4,000 times 96 plus 4,000 times 96 plus 96 squared. Now, from here, $4,000 squared, well, this is simple because all we have to do is 4 squared, which is 16, and then 1,000 squared, which is a million. So a million has 6 zeros, so all we have to do is add 6 zeros to the end of this. So I get 60 million, it's 4,000 squared, plus 4,000 times 96. Well, 4 times 96 is 384, so then all we have to do is add 3 zeros to that. So I get 384,000, and then this should be 4,000. So plus, again, 4,000 times 96, which is 384,000, plus 96 squared, which is 9,216. So now all we have to do is add all of these up, which is fairly simple. So I get 16 million plus, let's first start by adding up 384,000 plus 384,000. So that's going to be 768,000 plus 9,216. And now this is equal to 16 million plus 768,000 plus 9,216, which is 777,216. And now for my final step, I just have to add this to 16 million. So we don't have to worry about the millions place. So I just get 16,777,216. So this is my answer to this problem. Now, if you haven't already, please make sure to subscribe and leave a like, because I have many more videos like this on my channel, which you guys can try to solve. And if you're up for challenges, I have a bunch of those as well. So please make sure to subscribe, and thank you. Bye.